So maybe this is the time to start my presentation. So today's title, my presentation title is Implementation Details of Ruby 2.0 Virtual Machine. So I'm Koichi Sasada from Heroku. So this is a 7 times disclaimer. So this is my 8th time RubyConf, but I can, my English is not gross. So if you cannot understand my English speaking, please read the slide. I wrote all of my message to the slides. So if you can't read these characters, please go the front of these seats. Okay, so let me introduce myself. So my name is Koichi Sasada from Heroku at Matz team. And I am a full-time CUB committer, and he is Nakada-san. He is also a full-time committer. This is a business time, so he is making a CRuby 2.0. he don't make any presentation, but and I'm a CUB committer. So I wrote a virtual machine, and I also helped Ruby 2.0 release. So I organized feature requests, and last week there are 200 tickets left, but now we only have under 100 tickets. But I sent an email to the Ruby core and Ruby dev mailing list over the 150 emails. So I'm sorry for spamming. Okay, so at first I want to talk about the Ruby 2.0. So Matsumoto-san says Ruby 2.0 is the 20th anniversary release of Ruby programming language. So this time, our policy is keeping the compatibility at Ruby level. And so feature request for the usability or performance, it is not high priority. So this is a roadmap of Ruby 2.0. So this is the goal of release. The next February, we need to release. So we will release several times. In this time, we are working on the releasing the 2.0 preview 1 just now. And we will release the preview 2 at the 1st December. And we will close, freeze the code at this Christmas, next Christmas, and release the release candidate 1 and 2. So this means that we only have 2 months. There are no 2 months, but only about 2 months to introduce a new codes. So if you have any requests, so ask Matz. So next, features of Ruby 2.0. I want to introduce all of features. So you can read the news file to read new features of Ruby 2.0. So there are many features or changes. So please check it out. So I finished about Ruby 2.0. So I changed my title. I want to change my title. Wait a minute. So let's start the lecture about how to make an interpreter. the lecture number 3. So this is a review slide. So to attend this course, so you need to finish the Ruby language basic. Of course, you know. Of course, you finished. And this course, I use Ruby programming language. As you know, Ruby is a very popular language. Of course, you know. And I use CRuby to learn how to make an interpreter. So CRuby has their own virtual machine written by one Japanese. And so this is also a review slide. So to make a virtual machine, we need to execute the instructions of virtual machine. So the program counter pointed the instruction which we need to execute. And usually we use the stack machine virtual machine, stack machine architecture to implement the virtual machine. So all on the stack machine virtual machine, all of values are on the stack. And stack top is pointed by the stack pointer, shortly SP. And we already discussed the comparison with the register machines virtual machines and stack machine virtual machines. So there are several advantages and disadvantages. I eliminate this discussion. So this is a figure of how to execute the stack machine virtual machine. So program counter pointed the first of the program instruction, and stack pointer pointed the top of stack. Then doing this instruction gets the value from local variable b and push the value on the stack, and the stack pointer incremented. And next, same thing, so push the value of local variable c. And last, execute the plus method. So push the two values from the stack top and calculates the b plus c. And then at last, pop the value of the stack top and push set the local variable a. This is a simple execution sample. So I already introduced several optimization techniques for the stack machine virtual machines. So people optimization at the compile time and make macro selection and direct threading and stack caching. So there are many optimization techniques. And also the virtual machine generator helps us building a flexible virtual machine building. So back to today's topic. We use this example, the one-line method, one-line Ruby sentence. So receive.selector, arg1 and arg2. Receive means the receiver, and selector means the method ID or method name. And arg1 and arg2 are arguments. Before method dispatch, making method dispatch, we need to evaluate the receive and evaluate the arg1 and arg2 and push them on the stacks. So after the procedure number 2, then the receiver and arg1 and arg2 are pushed on the stack. So after that, we dispatch the methods. So we have, this is an overview of method dispatch process. So there are several processes. So at first getting the class of receiver and search the method body from the class and dispatch the method with checking something and the store the registers and building a local environment and set a program counter. So at first method, so we need to method search from receiver class. So in object-oriented language, there are hierarchy of classes. So in Ruby's case, the basic objects are inherited, and the inheritance hierarchy is this. And we need to search the methods for selector, for C2 and C1 and object and kernel and basic object. When we can find a selector at the C1, we can get the method body. In Ruby's case, if there are no method found, then method missing will be dispatched. And checking arity. Arity means how many arguments the method have expects. So compare with the given argument number and the expected argument number. Of course, it is different, then cause argument error. And checking visibility. Ruby has 3 visibility: public, private, and protected. So I can say which is what. I need to see the source code of Ruby virtual machine to understand which is what. So maybe you know. And we need to build a local environment. So each method has local variables. So we need to store the local variable and store the local variable. So we prepare the local variable space from at the stack. So extend the stack and prepare the local variable space. So we say this space as local environment, or environment shortly, in short. So especially the parameters are also in environment. So this is a figure. Before the stack method dispatch, stack is receive and arg1, arg2, this order. And after the method dispatch, we prepare the local variable space to with using extending the stack. And the top of environment are pointed by the environment pointer, shortly EP. And EP can point the every local variables. For example, using the EP0, index EP0 is local variable 2, and so on. This index of local variables can be calculated at compile time. So again, this slide shows again, this is the overview. So there are about 7 steps. So it's, as you can see, it is a very simple, but a bit slow, maybe you think. So this is a lecture, so I want to ask the quiz. So I show the 7 steps overview, but Ruby is more complex. In Ruby case, it is more complex. So what do you think about how many steps Ruby need to make a method dispatch? What do you think about 8 steps? 12 steps? Oh, 60 steps? Oh. Most of people select the 60 steps. So the answer is the 20 steps. So in Ruby's case, we need to make such a complex method dispatch processes. So next quiz is we have we use several method type. For example, the most of the case the method is defined by a def keyword in Ruby script. So this is one type. And also, you can load a C extension library written in C programming language, and the method type there is a method type defined by a C function. The C function method is only calls a C function. So there are at least two types, but there are more method types we implemented. So this is next quiz. So what do you think about this? So what's the number? What do you think about? So three types. 6 types. Oh. 9 types. Oh. Thank you. Most of people understand this system. So we implemented the 11 method types. So such things defined as the method.h in C Ruby. So there are many types, different method dispatch procedure we implemented. So we use a dispatch switch case statement in C language at every method dispatch. So this is the last quiz. So I introduced the virtual registers, program counter, stack pointer, and environment pointer. But Ruby has more virtual registers. So what do you think about the? So if you please raise your hand if you think it is 4 registers, 6 registers, 6 registers. Oh, ever. 9 registers. 9 registers. Ah, most of people understand the system. So, all right. So, what do you think about how many registers? 11. Nice. 11 registers. So this means that we need to store the 11 registers for each method dispatch. So it is very costly, for we need to reduce the register number. So at the 193, we use 11 registers, but at the Ruby 2.0, we use only 10 registers, but it is a big number, so we need to reduce. And we introduced the control frame stack to store the registers to maintain the method frames. So each method frames builds control such registers. So it means that this is a figure of the structure of value stack and control frame stacks. So this is a method. We need to build a control frame for each method. So we store the such 11 registers and point the such things. Okay. And also, Ruby has many complex features like parameters. So Ruby has mandatory parameters, optional parameters, and post parameters, and rest parameter, and block parameter. And after Ruby 2.0, we introduced keyword parameters. So we need to process this for this complex parameters. So we need to every method dispatch we execute such a complex processes. So this figure shows how method dispatch consumes the consume time. So at the Fibonacci benchmark, it's a micro benchmark. The method dispatch consumes a quarter of time, quarter or 1/3 time of all of execution time. And the pentomino solving puzzle, we need about 10% method dispatch time. So we need to reduce the method dispatch time. So reduce the method dispatch time is important. So this is a homework. So please report method dispatch speed-up techniques, analyze the method dispatch overhead of your favorite application, and survey method dispatch speed-up techniques, and propose your own optimization techniques to improve the method dispatch performance and to implement techniques and evaluate their performance. The deadline is there, and this report is important for your grade. All right? So lecture was finished. No. Presentation is not finished. So this is a report of this homework. So optimizing techniques for Ruby's method dispatch. So we implement three new optimization techniques to speed up the method dispatch. So this is the main topic of today's presentation. So summarize the method dispatch overheads. So there are several processes. So we need to skip or eliminate such processes. So at first, we use a specialized instruction. For example, the fix num plus is very frequent. Maybe you use frequently. So we need to reduce the execution time of fix num plus. So we use a special virtual machine instruction to do fix num plus. And we use plus, minus, or times, or some other special methods. So this code shows the specialized instruction code in Ruby. So checking the receiver as is it a fix num or object is a fix num, and the fix num plus is not really defined, then we can use the fix num plus optimized method without building method frame. So it is very fast. But if this condition is false, then using the ordinary general method dispatch code. So there is an advantage and disadvantages. So eliminate all dispatch cost. So this technique has very effective for only a few methods. So if we make each instruction for the C method, then it reduces the virtual machine performance. So it is a very limited method. And if we use a plus method for other classes, for example, the fix num, then we need additional overhead, the checking overhead. So this is an advantage and disadvantages. And we use method caching. I explained the naive simple method search algorithm from this class hierarchy, but we can cache the result of method search. So we use two types method caching
So one is the inline method cache. This has only one cache entry for each call site, and Ruby process has one global method cache table. It has hundreds of entries. So we use two types caching. So this technique are implemented from the Ruby 1.9. So here, this is from Ruby 2.0 technique. So the next technique is caching the checking result. I explained that we need to check the arity or visibility, but this check can be eliminated, can be skipped after the first checking. This means that if there is a loop and the same call site at the same call site, and the first method called dispatch, if it is skipped, then we can eliminate the checking of this checking. So so after the checking the first time, then cache the result of such a checking result into the inline method cache entry. So if inline method cache are hit, so we don't need to search methods. Then we can skip this checking. So this is the main contribution of 2.0 for method dispatch speed up. And we prepare the frameless C function framework. So introduce a frameless C function methods. So several methods, such as string length, don't need building a new method frame. So if the method is a frameless C function, then we eliminate the the building frame. So we can skip these processes for some methods, like a string length. So there is so it is a similar technique similar technique to specialized instruction, but compared with specialized instruction, we can use ultimate number of frameless method, but it is a bit slower than the specialized instruction. And I show you the evaluation result after that, but this technique are not included. And I prepared the special parts for the send and method missing from 2.0. Actually, we make a technique. We implemented the technique for the send method, but we refactoring and speed up given. So before this technique, this optimization, we call the send method, send C function methods, and then send method calls the foo method. But after this optimization, if the we call the send foo, then search the foo directory. Not we call the method foo directly and return this method call. So this is a micro benchmark result. This graph shows how faster than this date, October 13th. October 13th. So because I implement the optimized technique from this date, So this is a daily build to the from the October 13th to the yesterday, October 31st. So we can see the several performance improvements. This is a simple method sending. So we can get 40% or 50%. There are typical optimization results. We can see this. We can see the speed up results. And for the application, several applications has 20% performance improvement, and several applications doesn't get the speed up. So we need to make more effort. So future, also as you can see, we need to want more effort to speed up the method dispatch. I want to restructure the method frame. So 11th or 10th registers, it is a very huge number of registers, so we need to reduce them and improve the yield performance. I only improve the performance of method dispatch, not the yield block invocation, so we need to reduce the block invocation performance. Ooh. So the conclusion of this report, method dispatch speed up, we need to make, Ruby's method dispatch is very, very, very complex. So, but we can see the 15% speed up for simple method dispatch with new Ruby 2.0 from Ruby 2.0. And we need more effort to achieve the performance to improve it. So this is the conclusion of this method dispatch report. And we introduced some other methods, some other optimization techniques into from Ruby 2.0. Yesterday, I practice this presentation. I consumed 40 minutes from to this slide, so I want to say there are no time to say, so I want to skip, but there are 10 more minutes, so I want to introduce several optimization techniques. So we introduced a flow technique for the 64 CPU operating systems to improve the floating number performance, calculation performance. And we prepare the lightweight backtrace capturing. So if you raise an error, then the backtrace, we need to build a backtrace to see the backtrace, to print out the backtrace. But most of the case, we don't need to get the backtrace if you don't see the backtrace. So we make a lightweight method and restructure a small restructuring of virtual machine stacks and instruction sequence data. And maybe most of people want to know the bitmap marking garbage collector and the required performance improvement by other people. So, but I don't have a presentation slide to explain that. So please ask me after this presentation. So this needs a long time. So I want to skip the details of the technique, but we can see some benchmark performance improvements. So most of micro benchmarks don't use floating number calculation. So some benchmarks uses some benchmarks use floating number, so we can see the performance improvements with this optimization. So I want to skip the detailed technique of this optimization. So if you want to know how to implement this, so please run the IEEE 754 floating number layout. The simple explanation, this technique embeds the value 64 bits, floating number to 64 bits value size. And this is an explanation of lightweight backtrace capturing. So as you know, backtrace is string array of string objects. So file name, method, and blah, blah, blah. But capture only instruction sequence and translate to string only when it is access. So it can only capture the instruction sequence data, array of instruction sequence data, and then when the backtrace are accessed, then translates this data structure to the original backtrace array, string array. So I have 5 minutes. So we will release Ruby 2.0 next February. So we need more effort, I think. So this graph shows the performance of performance overhead analysis, the same graph I explained. But this graph is for the RDoc and Rails application. I'm not sure what kind of a Rails application, but this in this kind, so method dispatch overhead is about 10%. But most of overhead is most of time are consumed at the garbage collection and C function, so like string manipulation or something. And at Rails application, the garbage collection time is here. And there so string manipulation or some other performance, some other parts consumes many time. So we need more and more other techniques. So as you can see, on Rails and other actual practical application, virtual machine is not a bottleneck. So, but I think the mathematical assembly computation, the virtual machine is a matter. So I will introduce some other techniques such as a compiler framework or something after the Ruby 2.0. And garbage collection. As you know, the generational garbage collection are required, but introducing the generational garbage collection makes a huge number of bugs, and we need to debug in hell, so we need more dependable way. So I have one idea, so I want to try to implement the Ruby generational garbage collection after 2.0 released, and parallelization. So I don't have any time or space to discuss about that. So please ask me if you want to know about that. So conclusion. So there are many tasks left even after Ruby 2.0. So conclusion is our challenge has just begun. So thank you very much.